And we're going to start to take a look at applications of exponential equations, specifically here in the context of the four basic interest equations. So we're going to be talking about money in this set of examples of exponential equations. There's four basic interest equations that are commonly used: simple interest, annual interest, compound interest, and compound continuously. So we're going to take a look at each of them separately. And just to give you an idea of what each of these means, in these equations, the variable A equals amount, really the final amount of an investment after it's been invested at a certain percentage rate for a certain time period. P is your principal. Principal is another way of saying your starting amount. R is your interest rate. Now, key here is that it's your interest rate in decimal form. T is your time unit, typically in years. And N is what we call compound intervals per year. When we get to compound interest, we'll explain that one a little bit more. But the first four variables here, A, P, R, and T, are the critical ones to understand. A is your total investment value after a certain time period. P is your starting amount, your principal. R, again, is your interest rate. And T is time. I would recommend pausing the video and writing this information down before continuing, just so that it's available to you as you do more problems. So now, to drill home this idea that interest rate needs to be in decimal form, let's take a look at a couple percentages here, because typically speaking, when we're talking about investment or money, growth or decay, whether we owe or whether we gain money, it's typically given in the form of a percentage. But in the equations, we don't want them in forms of percentage, we want them in form of decimal. So how do we take a percentage and turn it into a decimal? Well, we take its decimal point and move it over two spaces to the left, so this becomes 0.07. Another way to think about that is take the percentage and divide by 100. 7 divided by 100 is 0.07. So 9.3%, again, taking that decimal place and moving it over, would be 0.093. Now, this one we have to be careful with because we're already in a decimal, but it's in percentage. So we still divide by 100 or move it over two spaces. So this becomes 0.004. And then the last example here, 11.8%. Again, moving that decimal place over, 2 to the left, produces 0.118. So it's going to be critical that we remember how to convert from a decimal or a percentage to a decimal for these equations. What I'd like to take a look at first is I'd like to take a look at an example and compare and contrast simple interest and annual interest. Okay. From the equations you wrote down, simple interest, if you remember, is A equals P times 1 plus RT. And your annual interest equation is A equals P times 1 plus R to the power of T. So the main difference between these two equations is the location of your T variable. With simple interest, T is down in the base with everything else being multiplied by R. In the annual interest, your T variable is the exponent. So what we want to do is we want to see how these produce different results and then describe what each is doing. So in the case of simple interest first, here's how we would plug this in. We know that a person has invested $5,000. That's our starting amount, which we learned to call principal. We're investing at 6%, and we're investing for 9 years. So we want to find the value of the investment after that 9 years. That's A. A is the final value. So in this case, our A is equal to our principal, our starting point, which is 5,000, times 1 plus, now careful here, R. R, remember, is in decimal form. So 6% in decimal form is 0.06. So that's what's going to go here. 0.06 times t. T is the total life of the investment, and for us that's 9 years. So there is my simple interest equation. Let's get our calculator out and find that value. So that's going to be 5,000 times, in parentheses, 1 plus 0.06 times 9. So plugging all that in, hit enter, and I get that my final amount is equal to $7,700. So after 9 years, with simple interest, $5,000 has become $7,700 invested at 6% over 9 years, earning simple interest. Okay, so if you compare beginning to end, we made $2,700. Let's take a look at what happens, though, with the annual interest equation. In the annual interest equation, we have the same variables, so we'll go ahead and start plugging things in. That's A equals P, principal of $5,000, times 1 plus, again, our rate in decimal form, 0.06, to the power of t, t being our time, which is 9 years. Okay, so calculator back out. Let's calculate this amount. That's going to be 5,000 times 1 plus 0.06. And I'm going to close the parenthesis off so it's a little bit different. Keep that in mind. And then to the power of 9. To the power of 9. Now hit enter, and I get the value of $8,447.39. So this is quite a different value. In fact, it's a little over $700 different in value than the simple interest equation. It's quite a bit more. So we might think that annual interest is looking way better than simple interest. So the question is, why do they produce different results? And why is annual interest a better deal, and probably what we want to lean towards when we do investment? So simple interest, here's how it operates. You have your starting amount of $5,000. So starting with $5,000, after 1 year, you have your $5,000 plus 6% interest. So that's 6% interest. Let's figure out what's 5,000 times 0.06 is $300. So at the end of a year, you have your $5,000 plus an additional $300 for a total of $5,300. Okay. Now at the end of 2 years, you get to collect that 6% interest again. However, it does not calculate the interest off of your new $5,300. In simple interest, it always calculates off of your original principal. So every year, you're just making an additional $300. So at the end of 2 years, you have $5,600. So at the end of 3 years, you've got your $5,600 plus, again, another 6% of $5,000, your original principal, brings you up to $5,900. So this just continues until you get to your 9th year, at which point you have $7,400, and you add that final $300 of interest to get that final $7,700. So that 6% is always referenced back to your original principal value, in our case of $5,000. So you're never earning more interest each year than the year before. You're always earning interest based off that original principal. So you're making the same amount every year. Now, in annual interest, things operate a little bit differently. In annual interest, you start off with your $5,000 again, and at the end of 1 year, you've got your $5,000 plus that extra $300, which is the 6% of the $5,000, for a total of $5,300. Here's the key difference, though. In year 2 now, at the end of 2 years, I've got my $5,300 plus I'm not earning interest off of my original $5,000 anymore. I'm earning interest off of my new value of $5,300. So I need to figure out what 5,300 times 0.06 is. So 6% of that is $318. So after 2 years, I don't just add a second $300, I add 6% off of the new value of 5,300, which is $318, and brings us to $5,618. So, and to see that again, if I go to another third year, I've got my $5,618. And again, I'm not earning interest based off of any of the previous values. I now have $5,618. I'm earning 6% interest off of that value, which is an extra $337.08. So 5,618 plus that extra 6% interest brings me up to $5,955.08 after 3 years. If you continue this process all the way down to year 9, this is where we will end up with that $8,447.39. So as you can see in comparison here, being able to earn interest off of interest, which is what annual interest is doing, is hugely valuable, because each year the 6% interest is bigger than the year before because you're calculating it off of a bigger number because of interest earned. So simple interest is a scenario where you do not reinvest your money earned in interest, whereas annual interest is a scenario where you are reinvesting the money you're earning through interest, so that every year your interest value is higher. Now, each of these have their own place. Each of these are significant in different scenarios, so they're both important to know. Typically, though, in an investment, a long-term investment scheme, an annual interest rate is typically the one that is used, because in long-term investing, interest earned is typically reinvested into your long-term goals. So let's take a look at annual interest a little more, just solve a couple more problems involving it. Okay. And then we'll end up taking a look at compound interest. So here's another annual interest. A person invests $10,000, so that's our principal, at 8% annually, so we know we're using our annual interest. It says, what is the value of the investment after 43 years? So again, the equation for annual interest is A equals P times 1 plus R to the T. For us, that's A equals a principal of $10,000 times 1 plus, let's see, 8% here, as a decimal is 0.08, so that's 1 plus 0.08, raised to the power of, well, we're investing for 43 years, so it's to the power of 43. Getting that calculator out. We can now go 10,000 times 1 plus 0.08, close that off, to the power of 43. And we end up getting A is equal to $273,666.40. So you can see there that over long term, an annual interest where you're reinvesting your interest earned can produce some pretty significant results. 8% interest, which is a reasonable interest rate when you're looking at long-term investment, of $10,000 principal, produces a little over $250,000 after 43 years, which is typically the length of a person's work life. So investing at the very beginning of your work life, right after college, and to retirement age around 65 years old, at $10,000, again, turned into $250,000. So let's look at one final annual interest rate problem. This one's going to be set up just a touch different. We're actually going to be given a piece of information that we're normally not given and asked to find a piece of information that we're typically given. So this problem says this: a person invests $4,000 for 11 years. At what rate annually do they have to invest at to have an investment value of $9,300? So to do that, again, we have this annually. Okay, so we're using the A equals P times 1 plus R to the T equation. And I have my principal here of 4,000. I have my year here of 11 years. I don't have my interest rate, but I do have what my final interest rate should equal. So in that context, here's what this is going to end up looking like. My A is my final amount, which I'm given as $9,300. And this equals my principal of $4,000 times 1 plus R. R is what we don't know. And we're invested for 11 years. So this is the equation now that we're going to be solving. But instead of simply simplifying for the value of A, we're going to be solving for R. To do this, I'm going to divide both sides by 4,000 because I'm trying to peel everything away from that R. Divide by 4,000. Okay. Let's do that. That's 9,300 divided by 4,000. Oh. That produces 2.325 is equal to 1 plus R to the 11th. Well, how do I undo an 11th power? I undo that with an 11th root. So 11th power, 11th root undo each other. So on the right-hand side, I'm left with 1 plus R. On the left-hand side here, how do I do the 11th root of 2.325? So in a graphing calculator, you first start by typing in the root value. So I'm going to type in 11, and then I'm going to hit my math button here. And I'm going to go down to option number 5, which is xth root. When I hit enter on that, notice how it takes the 11 and puts it in the root location on that radical. Now, if you have an older graphing calculator, TI-83 or an older 84, it won't actually bring that 11 up into the root position. The 11 will stay out front, but it's still going to be doing the 11th root. Doing the 11th root of 2.325. And that is 1.08 if we round that up, because of that 9 and the 7. Okay, so to finish this off, to solve for R, I'm going to subtract 1 from both sides, and that produces R equals 0.08. Well, 0.08 as a percentage is 8%. So in order to turn $4,000 into $9,300 over 11 years, we need to invest at an interest rate of 8%. So that takes us through an understanding of simple interest and annual interest. What we'll do next in the next video is we'll talk about compound interest.